Okay guys, as we continue our study of derivatives, we're going to go a little more into detail. In the last set, you were able to do product quotient rule and all that good junk, and we're going to just kind of start talking about applications. So the first thing we're going to talk about is a horizontal and vertical tangent. A horizontal tangent occurs when the derivative is equal to 0, and a vertical tangent occurs where the derivative is undefined. Okay, so if you have a fraction, you're going to set the bottom of the fraction equal to 0. So on the first example problem, I'm going to take the derivative. So I get f prime of x is equal to 15 x to the fourth minus 45 x squared. Okay, so they have a 15x squared in common, so I'm going to factor that out. So we should get x squared minus 3. Okay, and I'm going to set each of those equal to 0. So I get x is equal to 0. And then whenever I set x squared minus 3 is equal to 0, I get x squared is equal to 3. So x is equal to plus or minus the square root of 3. On the next one, I have to take the derivative. So I'm going to have a quotient rule. So f prime of x is equal to, right the bottom, derivative of the top is 5, minus right the top, derivative of the bottom is e to the x, and it's all over the bottom square. Okay, so I'm going to simplify the top out just a little bit. So I'm going to get 5e to the x minus 10 minus 5x e to the x minus, so we'll change the sign so it's plus 4e to the x. So we will get 9e to the x minus 5x e to the x minus 10 all over e to the x minus 2 quantity squared. Now, what we're going to use is that doesn't factor, so we're going to use our calculator to make sure it doesn't equal to 0. So I'll put that in my calculator, 9e to the x minus 5e to the x, 5x e to the x, sorry, minus 10, and I'm going to hit graph. Okay, so looks like we're going to have horizontal tangents at those two zeros. We got one here and one here. So x is equal to 0.264. And on the bottom, you should get 1.194. Now, your vertical tangents are going to occur where the bottom's equal to 0. So e to the x minus 2 is equal to 0. So e to the x is equal to 2. So x is equal to natural log of 2. Okay? So that's how you find vertical and horizontal tangents. Equation of the tangent line. So when we take the equation of a tangent line, we find the derivative, and then we plug in our x value to find the slope of the tangent line. And then if we're looking for a y value, you always plug it back into the original. Okay? So if I'm finding the normal line, remember it's perpendicular slope. So I'm going to take my derivative. F prime of x, derivative of tangent is secant squared times 2, secant squared of 2x times 2. Okay, now I'm going to plug in my pi over 6 into the derivative to get my slope. So 2 times pi over 6 is pi over 3. Secant of pi over 3 should be 2. 2 squared is 4. 4 times 2 should be 8. Okay. Now, so you have to know your trig chart. So when we go to get our y value, we plug back into the original. Tangent of pi over 3 is going to be square root of 3. So my tangent line is going to be y minus square root of 3 is equal to 8 times x minus pi over 6. My normal line is y minus square root of 3. And then I'm going to flip this slope and I'm going to change the sign. So negative 1/8 times x minus pi over 6. Okay. Next one, find the equation of the tangent line. So I'm going to take my derivative, y prime, is equal to, so when I take the derivative of e, I get e to the u du. And then I'm going to plug in my x value up here. So negative 2 times 2 is negative 4, plus 4 is 0. E to the 0 should be 1. 2 times 2 is 4, minus 2 is 2. So your slope is going to be 2. So my equation of my tangent line is y minus 1 is equal to 2 times x minus 2. And if you want to put that in y equals mx plus b, be my guest. We're just going in point slip form for now. Okay, last one of these examples. Find the equation of the tangent line for this. So I'm going to take my derivative. I'm going to write the first, derivative of the second, plus write the second term, derivative of the first, okay, and then I'm going to be operating at x is equal to 1. I'm going to plug in a 1. So this goes to a 1. This goes to a 1. That's 10. 10 times 2 is 20. So it comes out to be 21. Now, I'm going to find my y coordinate by plugging into the original. So 1 to the 5th power is 1. 1 times 2 is 2. So my equation of my tangent line is y minus 2 is equal to 21 times x minus 1. Okay? Higher order derivatives. So this means we're going to take our first derivative, second derivative, third derivative, that sort of thing. Okay, it says find the second derivative for the function given right there. So f prime of x, we got a product rule. So write the first. Derivative of the second is negative 3 e to the negative 3x. Plus, write the second term. Derivative of the first term is 2. Now, what will make this easier is factoring out the e term. Okay, the e to the negative 3x. So once I factor that out, I'm left with negative 9 minus 6x plus 2. Okay, so this will go to a negative 7 minus 6x. Okay, now when I go to take my second derivative, I don't have to do two product rules, I just have to do one. So we're going to write the first term. Derivative of the second term is negative 6, plus write the second term. Derivative of the first term is negative 3 e to the negative 3x. Okay? And you can leave it like that. We're not really trying to simplify too much. Okay, d squared y over dx squared means the second derivative. So I'm going to take the second derivative of that. So f prime of x is 9x to the 8th minus 28x plus secant of x tangent of x. So I'll end up having a product rule right here. So I take the second derivative. 72 x to the 7th minus 28. I'm going to write the first. Derivative of the second term is secant squared. Plus, I write the second term. Derivative of the first term is secant x tangent x. Okay? And if you want to simplify, be my guest. Okay, implicit differentiation. So we use implicit whenever we have x's and y's in play. Okay, so when we take the derivative of y, we have to follow it by dy dx. Okay, so In this first example, we're going to have a product rule here and a product rule here. So we're going to write the first, derivative the second, plus write the second term, derivative the first term is 4x. Okay, we got another product rule, write the first, derivative of the second, plus write the second, derivative the first. And then the derivative of sine is cosine. We're going to keep the angle. And then we're going to take the derivative of the angle. So the derivative of x is 1. The derivative of this is 2y dy dx. And I probably didn't leave enough room for this. So let me get some paper really quick so we don't run out of room. Okay. So what we want to do is we want to distribute everything and collect our x and y terms on one side and our dy dx terms on the other side. So I'm going to distribute that out. Now you're going to have to distribute this cosine to both of these terms. Okay, I'm going to move all my dy dx terms to the left-hand side. And everything else is going to move to the right side. Okay, and then this y term. And our last step. 1, 2, 3, 4, 5, 6. Okay, I have all my terms. Your last step will be to factor out a dy dx and divide everything to the other side. So dy dx comes out to be cosine of x plus y squared minus 4x squared plus y all over 4x squared y minus x minus 2y cosine of x plus y squared. So that's a doozy of a problem right there. Okay, so let's look at the next example problem. We'll probably have to go to another sheet of paper too. So we're going to use implicit again. And we've got a product rule in this term. So write the first, derivative the second, plus write the second term, derivative the first, minus 3, and we got 3y squared dy dx, and the derivative of negative 3 is 0. So we're going to collect all our dy dx terms on the left side. We're going to move everything else to the right side. Okay, and then we're going to factor out a dy dx and divide it over. Now on this question, we are going to be plugging in. Okay, so it says we're going to plug in a -1 for x and a 2 for y. Okay, so we got 4 times 2 is 8. So that should come out to be 11 on top. And then we got 4 minus 12 on the bottom. So it should come out to be negative 11 over 8. Just double checking my math. 2 squared is 4, 3. Yeah, looks good. Okay, so that's how we do implicit. Okay, this next one, we're going to do implicit again, but this time we're going to find the second derivative. So when we take the first derivative, we go 4x cubed minus sine of y dy dx is equal to 0. Now, we're going to solve for dy dx. So this one's actually probably easier if you move the sign to the right side. Okay, so dy dx comes out to be 4x cubed over sine of y. Now, to find the second derivative, we're going to have to do a quotient rule. So d squared y over dx squared. So write the bottom, derive the top, it's going to be 12x squared, minus write the top, derive the bottom is cosine of y, dy dx, all over the bottom squared. Now, what we're going to do is we're going to draw a nice little arrow, and we would plug in dy dx right there. Okay. Next example problem. It says, given the curve x plus xy plus 2y squared is equal to 6, find an expression that represents the slope for all of these. Okay, so the derivative of x is 1. We got a product rule. And then the derivative of this comes out to be 4y dy dx. The derivative of 6 is 0. Okay, so we're going to keep our dy dx terms on the left side. And all our other terms we're going to move to the right side. Okay, so dy dx comes out to be negative y minus 1 all over x plus 4y. Okay, it says write the equation of the tangent line to this point. So using this up here, we're going to find the equation of the tangent line. So your m, we're going to plug in a 1 for y, so this comes out to be negative 2 over, plug in a 2 plus 4 is 6, so it comes out to be negative 1/3 for your slope. So your equation of your tangent lines y minus 1 is equal to a negative 1/3 times x minus 2. Now, most of y'all missed this on your test whenever we took this test. So it says find all the other coordinates on this curve with the slope equal to the point, same as 0.21. So its slope was negative 1/3. So what we're going to do is negative y minus 1 all over x plus 4y is equal to a negative 1/3. And all we're going to do is cross multiply. Okay, so we're going to get, so let's do negative 3 minus 3 is equal to a negative x minus 4y. So I'm just multiplying, cross multiplying and distributing. Okay, I'm going to solve for y equals. And that's what I get. Whoa, no, sorry, I messed up. Don't skip steps like I did. Move your y's over here. So y is equal to negative x plus 3. and that should give you the right answer. Okay? Linearization. Okay, linearization is just using the equation of the tangent line to estimate a value. So on this example, I want to use the equation of the tangent line, so that's what I'm going to do first. So f prime of x is equal to 3 times 3 is 9, not 27. 9x squared minus 6. Okay, now if I want to use the slope, 2 squared is 4, so it's 36 minus 6, so it comes out to be 30. Now, remember, to find your y-coordinate, we plug into the original, if we're not given it. So, your y-coordinate's going to be, let me just double check in my calculator for the sake of time. Okay, so your y-coordinate should be 16. So the equation of the tangent line is y minus 16 is equal to 30 times x minus 2. Now, if I'm estimating the y value, I'm going to plug in the 2.2. And solve for y. So 2.2 minus 2 is 0.2, which is 1/5, times 30 is 6. 6 plus 16 should come out to be 22. Okay? Now on this one, last example on this page, it says for the function, you're given the derivative, okay, the slope. And I want to use this tangent line approximation for the function. What is the approximation for is equal to 2 found by using, I'm not sure this question makes any sort of sense at all. So let's just exit out. I'm gonna have to look at it. I might have mistyped something. Okay. Okay, let's look at how to do derivatives with tables. I would say there's a very good chance for this year's AP exam, the 2020 AP exam, that you're going to see a lot of tables and graphs on your questions. So it says we're going to use the table above and this function right here. And I want to evaluate h prime of 1. So h prime of x, we got a product rule, is going to be right the first, derivative the second, which is just going to be g prime of x, plus write the second term, derivative of the first term is going to be 2f prime of x. And I'm going to plug in my 1. So 2 times f of 1 plus 3, g prime of 1, plus 1 plus g of 1, and 2 times f prime of 1. Okay, so I'm going to read from the table. F of 1 should come out to be 3. Okay, so 2 times 3 is 6. 6 plus 3 is 9. G prime of 1 is 4. Okay, g of 1 is a negative 3, so 1 plus negative 3 is a negative 2. And f prime of 1 is a negative 2. Negative 2 times 2 is a negative 4. Okay, so 36 plus 8 should come out to be 44. Okay, and these are more table questions that I pulled. Let's just take a look at, for the sake of time, let's look at some ones that involve chain rules. So I'm going to do B and E and F with you. Okay, so when I take the derivative of this, it's f prime of g of x times g prime of x. Now, we're going to plug in a negative 1. Okay, g of negative 1 is a negative 1. So I'm going to cross that out. F prime of negative 1 is 2. G prime of negative 1 is 1. So your answer should come out to be 2. Going back over here. G prime of f of x times f prime of x. And we're evaluating at negative 1, so don't forget to plug in everywhere. Okay, so f of negative 1 is 0. G prime of 0 is 4. F prime of negative 1 should be 2. So your answer should come out to be 8. Okay, now working outside in. G prime of x plus f of x, and then I take the derivative of the inside, which is 1 plus f prime of x. Now what I'm doing is I'm evaluating this at 0, so I'm going to plug in a 0. Okay, f of 0 from our table. So f of 0 is a negative 1. F prime of 0 is a negative 2. So this is g prime of negative 1 times 1 plus a negative 2 is a negative 1. Okay, so g prime of negative 1 should be a negative 1 times a negative 1 should come out to be a positive 1. Okay, and if you want to finish those other examples on your own, more than welcome to. I'm just kind of running out of time on my video from my phone. Okay, the last type of question is if we have a graph. Okay, and so we can read the y values and the slopes from the graph. So for p of x, so p prime of x is equal to right the bottom, derivative the top, minus right the top, derivative the bottom, all over the bottom square. And I'm going to plug in a 1. Okay, so f of 1 is the top line right here. So f of 1 looks like it's 4. G prime of 1 is the slope at 1, so it's going to be this other line. So it looks like it's going to be negative 1/2. Remember, rise over run. G of 1 is 2. And f prime of 1 is 0. It's a horizontal line. And then f of 1 we said was 4. So it should be negative 2 over 16, which is going to be a negative 1/8. And the last example problem is just kind of like what we just worked. Okay, so s prime of x is equal to g prime of f of x times f prime of x. We're going to plug in a negative 5. Okay, f of negative 5 from the graph is going to be a negative 1. Okay, so g prime of negative 1, so what's the slope at negative 1? It's still going to be a negative 1/2. And f prime of negative 5, f prime of negative 5, slope of this line at this point should be down 1 over 2, so it should be negative 1/2. So your answer should come out to be 1/4. Now, hopefully I didn't make any mistakes because I was working through this quickly, and some of these problems were a little bit difficult. So hopefully this helps you get through derivative homework set number 2, and hopefully you have a good evening. Thanks.